classified one of these two categories, first one or second one. So the output is, even it is a bus, it is just giving as a car. You give anything to the supervised learning, it will give you just car or bike. It will not give you any other thing because the system is learned only car and bus. So it will not give you any other thing. Okay. So this is how a supervised learning is going to be applied. Like, so it is do the classification and then you going to give you the output is a car or a bike. So let's say this is like a classifier. So we use the classification or a classifier. So let's see a simple picture. Let's say this is a data set. This data set will have some elephants and some tigers. So this is like a classifier. Now let's see this data is given to this classifier. Now we ask the classifier, identify this animal. So then classifier will give the output as an elephant because it's already learned from this data set. Now, one more, we have the data set like this. It is nothing but is a regression. Regression is nothing but, so we have the continuous real values. Output values are going to be a continuous real values. So this is basically we use it for stock markets or house price prediction or some problems related to this. So this technique is called the regression. So classification and regression, these two problems are supervised because based on your truth value, we are going to get the output. So here we are going to use the classifier and regression models in supervised learning because the decision is based on this classification and regression problems. So which we say this is as an experience. So supervised learning is going to give you results based on the experience. So we see different supervised learning algorithms. So we have different types of algorithms of supervised. Some of the algorithms like k nearest neighbors algorithm or linear regression, logistic regression, or support vector machine SVMs, or decision trees, or random forest, or neural networks. So all these are some of the algorithms related to supervised learning. Now let's see what is unsupervised learning. So in unsupervised learning, we have the data set. So same like previous one, but we don't have the labels. So we don't give their names, car or bike. So in unsupervised learning, we don't give the labels or truth values. So we don't give the labels to this unsupervised learning. What we do instead, we do the clustering. So in clustering is nothing but we identify the pattern. So these two looks like a similar pattern. So then we group together. And these two looks like a similar pattern. Then we group together. So this kind of grouping is called clustering. So in unsupervised learning, we don't give their names or data sets, labels. Just give the data set and based on their patterns, so they are going to be grouped into one group, one object. So this process is called clustering. So after clustering, we see association rule mining. So if we see the car, the associated with the car is a diffuser. So or you use the bike, then associated is a helmet. So you associate based on your patterns or based on your object. So this is like association rule mining. So these are rules associated with the cars or bikes or any data which you give. So this is like a unsupervised learning. So now you can see in unsupervised learning, we just give the pattern and we don't know output are used like supervisor learning or reinforcement learning. No outputs are used. So just the learner is provided only by unlabeled data. We just give the data a data set without any labels. No feedback is provided from the environment. So that means we don't give any feedback in unsupervised learning. So, so this is learning what normally happens. So that means we don't give any input, any feedback. So no output, and we use the clustering techniques. That means grouping similar instances or similar things. So we use this kind of unsupervised learning in various applications like customer segmentation in customer relationship management or color quantization. Generally, we use in image compression and bioinformatics. So that means in learning motifs. So this is nothing but we use this in a protein, different types of sequence or pattern associated with the protein or a DNA. So identify this. So we use these unsupervised learning techniques. So just now we have finished like supervisory and unsupervised learnings. So in unsupervised learning, what we do, we have a data set. From this data set, we make the clusters like based on similar patterns. So we make the clusters, and then his system is going to learn based on this. So and another example is like suppose in a online shopping you purchase this computer like monitor and CPU. Once you buy these two items, your online platform, even Amazon or Flipkart, okay, it will show once you buy this, it will show customers who viewed this item also viewed. So once viewed this, they also see this. Or who purchased, they also purchased this. So in especially in Amazon, you see this. So once you buy this, the system will suggest the associated. So the what are the associated with this computer? Those things will be displayed automatically. So that means the system is learned based on its past experience. So that is how a unsupervised learning is going to be happen. So uh, these are some examples of unsupervised learning. So in unsupervised learning, so most of the laws of science are developed by using this unsupervised learning, and so but the main problem is like identifying the features. So that is a big problem. So when you have unsupervised learning, so these are certain advantages and disadvantages with unsupervised learning. So the third one is like reinforcement learning. As I said, reinforcement learning is also known as trial and error method. So here the learning is possible from the trials and errors, or you can say like from the mistakes. So based on your mistakes, so you can learn. That is like reinforcement learning. So in machine learning, so this is a most popular and most of us use this reinforcement learning. So especially in electric vehicles. So we use this reinforcement learning. So in reinforcement learning, it is in between like supervisory and unsupervised learning techniques. Here, labeled and unlabeled data is required for training. So it is a combination of these two. And of course, you need a reduced amount of supervision compared to this supervised learning technique. And at the same time, improving the results of unsupervised clustering to the expectations of the user. So we say it is improved application of these clustering techniques. So let's say one simple example of reinforcement learning. If you see this simple picture, Here you have a small dog and here a person. So here you can see this is we say agent and this is like environment. So once this dog approaches to this environment, so that means once agent approaches to the environment, so so it is like actions. So then this environment has to react. So this we say based on based on this reaction, we say like rewards or feedbacks. So based on this action, so we can give the rewards or maybe the feedbacks to improve this action, to overcome this action. So let's see another small example. Suppose a small baby, we say it's agent. So the family is like an environment. So once the baby use this glass, so or maybe this bottle. So we say glass is not possible, the bottle is okay. So we can say once the child use this glass, let's say you have like punishment. But once the baby use this bottle, we say it's like a reward. So the baby is learning based on its trial and error method. First use this, you have the punishment or the feedback. But once you use the bottle, we say it's a reward. That means you have similar to the actions. So you have the rewards or you have the feedbacks. So the system is going to learn from the actions and you act like a rewards or feedbacks. So so in this case, it's like a feedback, and in the other case, it's like a reward. So the baby is learned based on the trial and error method. So this is nothing but a reinforcement learning, a simple example of reinforcement learning. So this is nothing but we learn based from the mistakes or trial and error methods. So in reinforcement learning, so it is a increasing importance in machine learning. So because you can use it's like a automation. So in automating methods of collecting data and then use like a unlabeled data. So this is most popular or increasing importance in a machine learning. Now, as I said, in machine learning, you will be having supervisory and unsupervised and reinforcement learning. In supervised learning, the model training is done by using the labeled data. But in unsupervised learning, we use unlabeled data. In reinforcement learning, so the learning is possible based on the state updates and feedbacks from the environment. So from the environment, the agent is going to learn. So action, state, and the feedbacks. And in supervised learning, as I said, you will be having classification based on its shape or its characters, and regression, so based on its real values. And here you will be having clustering. This clustering is possible based on your type of data, similar type of data. So similar things can be clustered together, and then the learning is possible from the clustering. So this is how a machine learning algorithms are going to be used or implemented in the real time. So these are all different for our studies. So in as I said, we have like three types of machine learning. So supervised, unsupervised, and reinforcement. In supervised, you will be having classification and regression. In unsupervised, you will be having clustering, associated rule mining, and dimensionality reduction. So you have the large amount of data. You can reduce fine tune the data, or you can reduce the dimensionality. In reinforcement learning, you can have two types of algorithms. One is like model free based algorithms, and another one is a model based algorithms. So there are different types of algorithms in each of these learning. So based on your problem, based on your application, so you need to choose one of these machine learning technique. So as I said, the machine learning techniques, like machine learning, you will be having supervised, unsupervised, and reinforcement. In supervised, you have classification and regression, and classification can be used for various applications. So, identify fraud detection or image classification, diagnostics, customer retention. So, these are all different applications of classification algorithms. In regression, you can use a market forecast, weather forecast, especially in electrical engineering. You can see like load forecast or price forecast or solar irradiation forecast or wind speed forecast. So you can use the regression models so for forecasting. Or in other engineerings or other background, you can use it for population growth prediction or estimating the life expectancy. So all these are for forecasting problems. So we can use the regression models. And in unsupervised learning, so we will be having the clustering. So customer segmentation. So you have different types of customers. So how to club them into one group. So you can use the clustering techniques and dimensional reduction, like feature extraction. So you can use the dimensional reduction techniques. And in reinforcement learning, you use it for robot navigation. So especially we use it for the navigation of self-driving car. So in electrical vehicles, we use a self-driving car, so we can use this robot navigation. So these are all different applications of machine learning. So you can see there are different algorithms of machine learning, and you have different applications of this machine learning. So this machine learning, you can use it for most of the applications, especially in interdiscipline. So we can use in electrical engineering, we can use this machine learning algorithms for solving various problems. So in machine learning, so you have different algorithms like for classification algorithms, regression algorithms, clustering algorithms, or decision making algorithms. So you have different types of algorithms for each of these category. So let's see some of the applications. So in brief, so applications of machine learning. So how you can use this machine learning for various applications. So you use this machine learning like traffic prediction, virtual personal assistant, or speech recognition, email spam and malware filtering, bioinformatics, natural language processing. So we can use machine learning for wide variety of applications. One of the example, like we say, face recognition. So for face recognition, we use this machine learning. So let's see, we train the machine, training example of a person. So we train a person images like this, and then you can test. So use these images again, and you can test. So we can use this machine learning for face recognition. And we also use this machine learning in medical diagnosis, maybe simple photo or MRI or CT. So everywhere we use this machine learning techniques for medical diagnosis. And also we use it for iris verification. So use this machine learning. And also we use this for handwritten digits. So to identify, so with the digits which are written by hand, so we can use this machine learning. And also we use machine learning for speech recognition. So in recent years, we use this application, and also we can use it for signature verification. So machine learning has a lot of applications in signature verification, and also like target recognition. So you have missile, so you can find the target. You can exact target can be determined. So by using this machine learning techniques, in nowadays we use like electric vehicles and self-driving cars. So to monitor the traffic, we use this machine learning techniques. So machine learning has different applications. So in different areas. So one of the object like one application of AI. So in recent years is a transportation. Especially we use this in object identification. Suppose you have like a bus or a taxi. So to identify object, so in case of self-driving cars, so we use this object identification techniques. So again, we also use a self-driving car. So in self-driving car, to identify the signals or to identify the other cars or objects or even the people or signals, so we use this machine learning techniques. So in case of self-driving car or self-driving mode of operation. So after this, like machine learning, let's see a brief about optimization. So what are the different optimization techniques and what exactly optimization and how it can be used in electrical engineering. So, so till now we see about like what are the different machine learning techniques and its importance and its introduction and its applications. Uh, let's see now optimization. So optimization is nothing but we all know is a mathematical discipline where we use optimization algorithm to find a maximum value or minimum value and subjected to various constraints, maybe equality or inequality constraints. The optimization problems can be classified based on type of constraints or nature of design variables, nature of equations, or deterministic nature or stochastic nature of variables, and values of design variables and number of objectives. So many. So you have different types of objective functions and optimization problems. So based on your variables or based on your nature, you need to find or you need to choose an appropriate optimization technique. So if you see classification based on permissible values of decision variables, that means your decision variables or your control variables are maybe integers or discrete values. So then you can use integer programming type of problem. But if your decision variables are only real values, in that case, you can use real valued programming problem. So you can use integer programming problems based on only integer or discrete values or only real values, then you can use the real valued programming problems. So based on the nature of your variable, you can use the type of objective function or a type of program. Again, classification based on deterministic nature of variables. That means if your design variables are deterministic, means they don't change with time, they are fixed. In that case, you can use deterministic programming problem. But in recent years, we use like renewable energy sources and electric vehicles. So in that case, the design variables are not deterministic. they are going to be stochastic in nature or probabilistic in nature, or we can say non-deterministic nature. In that case, we need to use or we need to uh, use like stochastic programming problem instead of deterministic programming problem. So based on your design variables,
மிட்டம் 2 என்னைக்கு ஆரம்பிக்குது விபா?
deterministic or stochastic programming problems. Again, based on number of objective function, you can classify, you can use a single objective programming problem or multi-objective programming problem. Suppose you have only one objective, then you can use single objective optimization. But when you have two or more conflicting objectives, then you need to optimize both objectives simultaneously instead of one objective. Then you can use multi-objective optimization. So if you see different types of optimization techniques. So in optimization techniques, you have conventional optimization techniques and non-conventional optimization techniques. In conventional optimization techniques, they are modeled based on mathematical programming or calculus methods or networks method. But in non-conventional, they use a meta-heuristic algorithms. So based on these meta-heuristic algorithms, so they are going to optimize. So in conventional techniques, so these are conventional and meta-heuristic, but conventional techniques can be used and they are going to give you the result. But if your problem is some kind of non-linear, then there is a problem with conventional techniques. So let's see what are the limitations of these conventional techniques. So most of the conventional techniques, we use gradient-based optimization. So, and gradient-based optimization techniques are nothing but we do some kind of linearization. Maybe objective function we do linearization, or constraints we are going to do linearization. So by doing this linearization, we are compromising on the accuracy of the algorithm. So the gradient-based methods have some kind of disadvantage by doing the linearization. But many mathematical assumptions we do, like convex, analytic, and differential objective functions, they are so that we can simplify the problem. But whereas all the practical optimization problems are highly nonlinear, multimodal, non-convex optimization problems. So because of these non-convex optimization problems, the conventional techniques cannot be used. So we need to go for meta-heuristic algorithms. So in meta-heuristic algorithms, again, there are going to be different algorithms. So some of like evolutionary algorithms are physics-based, SWAM-based, or human-based. So there are different algorithms. So based on evolutionary, you can say like genetic algorithm, or simulated annealing, or whale, or ant colony, or PSO, teaching learning-based algorithm. So all these are different optimization techniques of meta-heuristic. Why we use these evolutionary meta-heuristic algorithms are because all our problems, so they are linear, non-linear and multimodal, and they are going to give you a global maximum point or global solution. They all are system independent. They are free from the complex derivatives, because conventional techniques, the derivatives is a big problem. But evolutionary algorithms, we don't need any derivatives. So it's free from the complex derivatives, so it can be used easily. And insensitive to initial values. All these evolutionary algorithms are insensitive to initial values. So these algorithms can be used over conventional techniques. In evolutionary algorithms, what we do, the general approach is like the basic evolutionary cycle of these meta-heuristic techniques is like You have the present generation. From the present generation, you do the selection. So then you do the selected parents. From the selected parents, you apply crossover and mutation operations, and then you get the new generation. Then replace the present generation with the new generation. So you repeat this cycle. So you repeat this cycle several times, then you are going to get you a best solution. Again, as I said, apart from the single objective optimization, you also have multi-objective optimization. So in multi-objective optimization, you will be having two or more conflicting objectives. So there is no unique solution to the problem. So you need some kind of high level solution, high level information to find the final solution. So in multi-objective optimization, we are going to get a Pareto optimal set. So which is get a large amount of solutions as diverse as possible. So from this, you are going to get a multi-objective optimization. So what we do in multi-objective optimization, we do many objectives and we subject it to equality inequality constraints. Then we use some kind of multi-objective optimization technique. Then we find a Pareto set. Then based on your knowledge, based on your experience, we do the decision making. Then you are going to get a final solution. So this is how a multi-objective optimization program is going to work. Now, let's come to the electrical engineering applications of this AI and machine learning to our electrical engineering. So, as I said, in electrical engineering, so we use a smart grid. In a smart grid, so we use all these components like we use electric vehicles, wind energy, solar energy, energy storage, and we give the customer also some options to choose the power. And all these components are possible in smart grid. So in smart grid, the major component is like renewable energy. So our theme of our faculty development program is like renewable energy sources or renewable energy. So let's see why we need this renewable energy. So why the renewable energy? This is a basic question. So we all know because the demand is increasing rapidly, and also natural sources like oil, coal, they are depleting very fast. So we need to meet all these demand in an equitable and sustainable manner. So to meet this demand in an economical and efficient way, we all should move towards renewable energy. Like we have different types of renewable energy sources like wind energy, solar energy, biomass, or geothermal, hydropower, and tidal and wave energy. So we have different types of different sources of renewable energy. So all these renewable energy sources are going to be uh, uh, have certain advantages at the same time certain kind of issues, certain kind of challenges associated with these renewable energy sources. But among these, the wind energy and solar energy, they have the major share of this renewable energy. So we concentrate mostly on this wind and solar energy. So when you have all this in our power system, so we say it's our power system is a hybrid power system. So in a hybrid power system, you will have like a grid, then you will be having the smart villages, smart cities, and smart homes, and you will be having electric vehicles. And once you have electric vehicles, you need to have proper infrastructure that is like charging stations and batteries. So these, when you have all these components, our power system is now become hybrid power system. So in a hybrid power system, we have like renewable energy, bidirectional EV charging, and also smart homes and buildings. So we have different components, and we need to integrate all of them to the system. So we say it is a system integration. Once you have the system integration, you need to optimize renewable energy for production as well as the usage. So there is a requirement for the optimization. The main problem with wind energy and solar energy, they are like variable and unpredictability, or intermittent, so or uncertain. So when you when these sources are uncertain, in the practical world, we need some kind of probabilistic models to handle these uncertainties. So whenever there is a uncertainty or intermittency, so we need to have some kind of we are doing some kind of randomness to the system. So whenever there is a some randomness to the system, this is going to create a challenge to the system operator. So system operator has to handle this variability or unpredictability in the system. So when you integrate this renewable energy into the electricity markets, because this renewable energy is not free. So the renewable energy, suppose you are a wind plant owner or solar PV plant owner, you cannot give it for the free. So you go to the market and sell, maybe non-market based or market based. So in non-market based means you make a fixed tariff, you and then you sell power to the grid. In market based, you will be having you go to the market, you bid into the market, and then you sell into the market. So there are two types of approaches for selling the markets, for selling the renewable energy, that is non-market based or market based sale. So apart from these renewable energy sources, we also have in modern electrical systems, we also have electric vehicles. So electric vehicles, we have many advantages. So like we have availability of the fuel, because we don't have the fuel for our for our vehicles. So we mostly depend on Middle East countries for the fuel. So this is one problem why we should go for the electric vehicles. And another one is the pollution. So if you replace all the vehicles by 100% by electric vehicles, the CO2 emission is going to be off. So is going to be off CO2 emission if you replace all the vehicles with electric vehicles. So when you use renewable based charging, even the carbon footprints is also going to be decreased drastically. But the problem is like capital cost is high, and of course the maintenance cost is low. So because of these reasons, we all moving towards electric vehicles. So in electric vehicles, so we can see no tailpipe emissions. Of course, the mileage is a little less, but still, the recent advances in the battery technologies, the mileage is increasing rapidly. And also, previously we used to charge 2 hours for the charging, but nowadays, because of fast charging, so the time is decreasing rapidly. Of course, the operating cost is very low compared to these gasoline vehicles, means like diesel or petrol vehicles. But initially, the cost of this electric vehicle is very high compared to these IC engine vehicles. But still, if you keep them in a balance, so if you use these electric vehicles for the 5 years or maybe 4 years time, so then cost of both the vehicles are going to be same. If you use an electric vehicle for 4 years or 5 years down the line, so the cost of both the vehicles are going to be same. Of course, you can say the battery has to be replaced. The battery can be mostly an average. The battery life may be some 10 to 15 years. So in that time, so if you use it and the cost of these both the vehicles are going to be same in down the line, maybe you can say 4 to 5 years. Now, so these are all advantages with electric vehicles, but there are certain challenges with electric vehicle from the grid point of view. So, as I said, electric vehicles are going to introduce some kind of intermittency or uncertainty to the grid. So, when you use electric vehicle, load is intermittent, so it is going to give you some kind of challenges. And also, maintaining the grid stability is also one of the problem when you have these electric vehicles. So, again, apart from these, we also use demand side management. So, demand side management means some of the customers, so they are willing to uh, reduce their demand. So, this is possibly when there is a less spinning margin or some of the generation is lost. So, in that case, we depend mostly on the demand side reserves. So, demand side reserves can be possible from a single home or an apartment, a building, or even from the electric vehicles. So they all can offer demand response. This is nothing but demand aggregator. So nowadays, most of researchers they are all working uh, electric vehicles. So some of you can think of doing these problems like optimal location and sizing of electric vehicle charging stations, or benefit maximization for the parking lot owner. All these are different problems, different optimization problems related to electric vehicles. So you can do, you can take one of these objective, and then you can do your research. So some objectives like maximize aggregator profit, or minimize the charging cost, or minimize total operating cost of the entire system, or maximize the revenue, or maximize the social welfare of grid operator. So all these are different objectives you can think and you can solve when you do your uh, optimization or when you do your research related to electric vehicles. Now, let's see how you can model these electric vehicles into the system. So, when you do optimization, so we need to model the electric vehicle into the system. So that may be in your load flow, in your optimal power flow problem. So in that case, what do we do? So generally, electric vehicles will play two roles. They appear like a charger, charging time. They appear like a loads. During the discharging time, they appear like a generators. So they can act like a generators or loads. So this behavior you need to model in your load flow problem. Maybe your Gauss-Seidel load flow, or Newton-Raphson, or fast decoupled load flow. You need to model this electric vehicle. For modeling this, you can see instantaneous charging status of this electric vehicle. You can model by considering this equation. So based on this equation, based on this exponential function and initial power of an electric vehicle, you can find the instantaneous charging status of a electric vehicle. Similarly, once you have this electric vehicle power, so there is going to be some uncertainty because we don't know when our electric vehicle is going to be charged and discharged. So in that case, you need to have some kind of probabilistic techniques to handle this kind of approach. That is like numerical approach or analytical approach. So in numerical approach techniques, we use a Monte Carlo simulation because to handle the uncertainty of electric vehicles. So Monte Carlo simulation, there are different sequential, non-sequential, and pseudo-sequential. But these methods, Monte Carlo simulation methods, are going to give you a better result. But the main problem with Monte Carlo simulation methods is nothing but it requires a lot of data and a lot of time to get the result. So to overcome this disadvantage, So we use analytical based approaches where we use some kind of probability density function approximation. So we use some kind of algorithms like this point estimate or convolution method, cumulants method. So we use these techniques. So based on approximation or based on linearization. So and then we are going to get the result. It's an approximation and linearization, but still we are going to get the result as closely as we get from Monte Carlo simulation. Now we need to model the uncertainty related to electric vehicles. So the electric vehicles data, it all closely follows the normal distribution function. So based on that, based on the normal distribution function, you can model the electric vehicles into the grid. So the main problem with electric vehicle is the charging. So charging times. So to overcome this charging problem, so we can use dynamic charging of electric vehicle, where once the vehicle travel on this road and this track, this power track, so the vehicle is going to be charged automatically. So that in that way you can reduce the charging time, and we don't need any separate charging for charging this bus. So this is one of the a dynamic charging technique, so can be used, but of course it needs a special track to be constructed. So this is one of the shuttle bus which is developed in our city. And also this is a simple electric vehicle charging station. So in Korea we have like a rental service provider or Hyundai station. So in Seoul city, so you have a large charging station. So this is how a charging station looks. So electric vehicle charging station. But electric vehicle charging, EV charging station also, we need to model in a load flow in your optimization. So the load of electric vehicle charging station you can determine based on how many vehicles are charging, and then based on how many vehicles are discharging. Based on the charging and discharging, so we can determine uh, the total load of this electric vehicle charging station. So load modeling with electric vehicle charging station. So because the load which we get is different from the practical. So in practice, the load is can be modeled by using different techniques, different models, maybe exponential model or Jeep model. So if you see, this is one of the model, like actual load is determined based on some function, based on the voltages. So actual system load, and this is a charging station load, EV charging station load. So this is how you can determine the charging status, charge total demand by using load modeling. Now, in electrical engineering, we use renewable energy sources. So we need to model how much power we are getting from a wind energy system or a wind plant. To get this, we need to use some linearization function like this, or we can use some quadratic function or cubic function like this. So power output can be determined a simple linear function or a cubic relation like this, or even quadratic relationship. So this is based on wind velocity. The power output is determined like this. So the again similarly the load and power probability distribution functions can be used to model the uncertainty related to this wind velocity or wind speed. Similarly, we can also use for the load uncertainty. So load uncertainty is also can be modeled by using some normal distribution function, so which is modeled like this. And solar power, so solar power is also can be modeled by considering the solar irradiation, that is G. So based on this solar irradiation, the solar power can be determined. So once you determine the solar power, so if you see this picture, Here you have a solar generator as well as the battery. So based on this solar power and the battery, the final output, which is you are giving to the system, that is PS. PS, because in load flow studies, we are interested how much power is injected at a particular bus. So how much power injected is a PS, is a PPV, this plus battery, which may be plus or minus based on your charging and discharging status, and spillage power. So battery power can be determined by charging status and the efficiency of the battery. So again, this solar PV is also uncertain because we cannot predict solar irradiation perfectly. So we need to use some kind of probability density function, maybe beta or viable or log normal function. So use this function and then you can determine the charging status of the system. So batteries also can be determined, so can be modeled based on the state of charge of the battery. So this state of charge of the battery can be determined by charge at a particular time. So the charge at a particular time can be determined initial state of charge plus charging and the discharging minus discharging. So this is how you can also model a battery in the system. Let's solve quickly one multi-objective based optimization problem. So where you have two or more objectives at a time, and then you are going to solve this. So for this, we use like a multi-objective based optimization problem. We use two or more objectives, and then we solve using some kind of multi-objective technique. So here we have like two objectives. One objective is like a cost minimization. So it is formed like this. And each term in this, so thermal generators, wind generators, solar, batteries, electric vehicles, and some kind of uncertainty, any deviation power can be determined. And then the cost equation is determined like this. And then wind power, solar power, and batteries, electric vehicles. So, and here you have like real time. So, how much deviation power is calculated or determined? How much power is deviated from the mean adjustment cost? So, this is how we determine and then we find the mean adjustment cost. So, here the second objective is like when you introduce more amount of wind power, solar power in the system becomes unsecure or risk. So you are introducing risk to the system. So in that case, you need to model the risk in the system. You need to minimize the risk. So this is one of the linear way you can model the risk. And another way is also you can use like a conditional value at risk. This is also one of the ways to model the risk in the system. So CVR, this is also you can model the risk and you need to minimize this risk. So that is your second objective function. So these objectives are solved by considering equality inequality constraints, the various equality inequality constraints. And this is solved by using multi-objective optimization algorithm, say non-dominated sorting based genetic algorithm. We say NSGA2. So this is a flowchart we used for solving this problem. So here we used a non-dominated sorting based genetic algorithm to solve multiple objectives. So we studied this problem, three cases. Case one is a cost minimization objective, two is the risk objective, and three is the both objectives together. So in this case, we performed these operations on 30 bus system, IEEE 30 bus system. Here only cost objective, then you got 965. But when you do the risk is less, but cost is more. So to get a best compromise solution, we use a case 3 where you get a best compromise solution. Both objectives are going to be optimized together. So these are the voltages associated with the three cases. So each case you can see the cost, the voltages are less. In case of risk, the voltages are high. But in case of this, the voltages are compromised solution, the voltages are in between. So the compromised solution. Similarly, you can also see the Pareto optimal friend. So one objective is a cost, other objective is a risk. So when you plot a graph between these two, you get a Pareto optimal set. So each dot here, each circle, each dot represent one possible solution. But based on your experience, based on fuzzy min-max approach, we have selected this point. So this point is called best compromise solution. So uh, with this, I am going to conclude my presentation. So here we have seen introduction of like machine learning and artificial intelligence techniques, and then we have seen how the electric vehicles, wind energy generators, solar energy generators, and batteries are modeled, and how they are going to be implemented in practical by considering multiple objectives at a time. Two objectives like cost and the risk objectives together, and then we solve the problem. So these are the references used for this work. And lastly, so I want to inform that so presently I am editing a book. So it's a book chapter invitation. So if someone are interested to submit a chapter to this book, so you can send me an email. So the book chapter invitation. So it is a Springer book. The title is like Green Energy and Technology. So it is a Scopus index. Each chapter, not the book, but each chapter, each of your chapter is going to be indexed in Scopus, and there is no publication fee. So I'm acting as the editor for this book. So the next generation green energy technologies for sustainable development. So which will be published in Green Energy and Technology book. So each book, each chapter, Scopus and EI Compendex and SCI Mogo also it is available. And there is no publication fee for this book, for this chapter. And the deadline for chapter submission is like February 28, 2025. So if somebody interested to submit this chapter to this book, so you can send me email. So this is my email. So surender@wc.ac.kr. So if somebody interested to submit any chapter, you can send me an email to this. Thank you. Thank you for patience listening. If you have any questions, so please let me know. Yes, sir. Thank you, sir. Thank you very much. If you have any questions, so please let me know.
Good evening, sir.
Yes. Yes, please.
Sir, in the AI in renewable energy sources, any theft is possible, sir, in renewable energy sources? AI, it will be anyone can hack our energy sources to malfunctioning in that way, in any way.
Yes. So, like theft means so you can only the data is possible. So for that we need to use some kind of security techniques. Maybe you can use like a blockchain techniques. So some kind of security techniques you need to implement. So for theft, any loss of data. So you can use blockchain technologies.
Okay, sir. Thank you, sir.
Yes. Yeah, if you have any questions, so please let me know. Okay, or you can also, yeah, if you have any question.
Am I audible, sir?
Yes, sir, you are audible.
Sir, good evening. I am from West Bengal, Haldia Technology.
Yes, sir.
I had one, maybe I have missed some words due to my internet connectivity. Regarding that, you have been showing a block diagram where you have shown that the PV charging, sorry, PV generator, then the flow chart is going to controller, then controller to your battery charging, then it is to inverter, and another arrow is going to battery, and that is going to, sorry, battery charger, and that is going to the there is a arrowhead from the bus to the charger. That thing I got some confusion over there.
Yes, sir. Yes, sir. It is basically power electronics. So those who are working in power electronics, so maybe you can get more details. So it is the main idea for the implementation is, so the power from the battery and power from the solar PV, so they are exchanged in like maybe from the solar it can be charged or discharged. So based on the charged, it may be minus, or maybe discharged it is going to be plus. So that whatever the power available, that will be given to the power system. So we are concentrating on how much power is given to the power system or at a particular bus. So it is just simple like a PS plus PB or PS minus PB.
Yes, I understood.
Yes,
Can I review that slide if possible?
yes, yes, sir. Yes. Okay, sir. You can
Yes,
see here. Yes.
yes, sir. This bus means this is a DC bus.
No,
Obviously,
this is like a AC bus here. So
this
the power which is given to the system,
yes,
complete
sir. Now
system.
this bidirectional arrow is provided from the battery charger. This one I have not understood.
Yes, I think this is a picture problem, sir. This.
Okay, okay, then it's okay.
Yeah, it's a bidirectional arrow is not there. Yes.
Okay, sir. Thank you.
Yes. Yes, sir. So if you have any questions, so please let me know. Yes. Okay, sir. Uh, it is based on your application. So suppose you have a lot of data, then you can use a deep learning techniques. So if you are not having any large amount of data, so simple optimization, then you can use the genetic algorithm. So it depends on your based on your data. Suppose you don't have any data, you just have simple data of the system, then you can use genetic algorithm. Yes. Yes, sir. Thank you, sir. Thank you, everyone. Thank you for your patience listening. Yes, sir. Thank you, sir.
So good evening, sir. Hello, Anil, sir. Sir, feedback is there for every session, sir. Feedback is there, sir. Feedback or a test link is there for every session. Okay, okay, sir. Okay, okay, sir.
It's my pleasure to introduce Dr. D.M. Vinod Kumar Sir Garu. Dr. D.M. Vinod Kumar Sir joined the NIT Warangal in 1981 as a faculty member. Sir was head of a Department of Electrical Engineering during 2007 to 9 and Dean Academic during 9 to 11. He was Deputy Chief Warden NIT Warangal Hostels and Chairman Library Advisory Committee during 16 to 18. At present, he is Professor of Electrical and Electronics Engineering at SR University Warangal. Sir obtained his BE Electrical Engineering and MTech Power System Engineering degrees from Usmania University, Hyderabad during 1979 and 81 respectively. Sir earned his PhD degree from IIT Kanpur in the year 1996. The title of his thesis is Artificial Neural Network Based Power System State Estimation. Sir has supervised 12 PhD candidates and also supervised undergraduate projects. Sir introduced for the first time in the United Andhra Pradesh NIT Warangal the subject Artificial Intelligence Applications in Electrical Engineering in 1996. Sir is co-principal investigator of the project Imprint